Here is chapter 7. On this part we have, this graph is for uniform probability density function. For a friend who is X minutes late. Part A, find probability that a friend is between 10 and 30 minutes late. Here on this part, this x-axis is for time and it's in minutes. And here height is 1 over 30. How we can find that is 1 over, here we have that number, minus the starting point is this one, so minus 0. So it's equal to 1 over 3. This is how we can find our height here for this part. And here again, same as bell-shaped empirical rule, total area is equal to 1, or probability or our area is equal to 1. And what it's asking for this part, it's asking to find probability when X is between 10 and 30 minutes. So we have to find the area for this part here. So area or probability is the same thing. How we can find it? Area is equal to length times width, and so we have to multiply what they have here, height, and find distance between 10 and 30. So 1 over 30 times. Here the distance between 10 minutes and 30 minutes. Subtract these two numbers. So it's 1 over 30 times 20. Simplify this part, write your answers and your answer in decimal number. And then part B, it is 10 a.m. There is a 30% probability the friend will arrive within how many minutes? So here again, same as part A. So exactly same as that part, but here on this part, what is given, 30% probability, meaning that our area is given. So it's 0.3 or 0.3, that is equal to height stays same. This part doesn't change. Multiplied by, it's asking to find minutes, how many minutes, so we have to find X. How we can solve this part, you can use cross product, or you can clear fraction. So let me just write this way, X over 3. So this is what we have. This means here in denominator, we have 1. So using cross product, 1 times X is equal to 0.3 times 3. So that's where we can find the answer. So what is the answer for that part? And that is in minutes. Or, so this is what I have. I'm just rewriting this part. Here denominator is, we have this number in denominator. To be able to clear our fraction, I have to multiply by both sides by 30 to be able to clear fraction. This way I can cancel that part, and what's left, I have X equal to multiply these two numbers. So that's the answer, and it's in minutes. Where we can use this kind of questions, for example, let's assume that you have ordered from Amazon and you're waiting for your package, and expected time to receive to your packages between 10 a.m. and 2 p.m. So it's 4 hours, and you're 100% sure that you will receive your package between these two, so this 4 hours, meaning that your probability is equal to 100%. But what if you're not able to wait for 4 hours and you can wait from 10 a.m. to, for example, 1 p.m. So you can wait for 3 hours instead of 4. And you're trying to see what is the probability to receive your package. So in this case, the probability is 75%, so it's not 100%, because you only can wait for 3 hours. So what we have here, between 10 and 1, we have 3 hours. And what we had here, originally we had 4 hours, so 3 divided by 4. So this is 0.75 or 75%. Now, number 2, so complete that part. I did everything. You only need to divide, find the answer for that one, and then find the answer here. And I said we have these 2 methods. You can solve using either one of these methods. Number 2, determine area under standard normal curve that lies to the left. So this is to the left. You don't need to draw these. I'm going to draw this one to explain what we have here. I will work on one of these. For example, z is negative 1.56. It doesn't matter if you have negative z-score or positive z-score. Just see what is asking, if it's to the left or to the right. So in this case, it's to the left. So here is 0, and we have negative 1. Let's assume that here is the point we have, negative 1.56. So it's set to the left of z. So we have to find area for that part. How we can find the area for that one, and this is exactly the same as number line. What we have on left side, starting from negative numbers. So here I have negative infinite, and on right side I have positive infinite. Having negative infinite, how we can enter negative infinite on our calculator? So for that part, we have to enter negative 1 exponent, so it's e to the power 99. So you have to enter negative 1 e 99. To enter e, you have to press second. So for this one, that is second. Then you have to press division to be able to enter e. Finding the answer for this part, probability when z is less than negative 1.56, that is equal to, we have to use this function, normal CDF. Normal CDF starting from left side to that point, here is negative infinite, so it's negative 1e 99, comma. Moving to right, our z-score is negative 1.56, comma, 0, comma 1. This is mean, this is standard deviation. For normal distribution, we always have mean equal to 0 and standard deviation is equal to 1. So for this part, we have to press second vars. Here we have number 2, normal CDF. Enter. Then we have to enter negative 1e99. It's negative, it's not subtraction. So negative is on your calculator is in bracket. So use negative 1. To press E, you have to press second division. Then 99. So this is what I have. And upper is our z-score is negative 1.56. This part doesn't change. Mean is 0. Standard deviation is 1. Enter, 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 enter. So here is the answer is 0.05937. I'm going to run to 4 decimal places. So the answer is 0.0594. That's the answer for part A. Do exactly the same thing for part B, C, and D. Again, it doesn't matter if your z-score is negative or positive. What matters is what it's asking here, if it's area to the left or right, and in this case is to the left. So you're gonna do exactly the same as what I did here. You just change that part, your z-score, and find the answers. So find the answer for B, C, and D. Number 3, now on this part, it's area to the right. Again, I will work on one of these and you have to complete all these. So part A. Again, you don't need to draw this. So between is 0 and z is negative 1.04. Let's assume that here is our z-score. Obviously, this is negative, and that should be to the left of 0. So this is exactly the same as number line. In between we have 0, on the right side we have positive numbers, and on the left side we have negative numbers. So for a negative infinite, you have to enter negative 1, E99. And here, positive infinite is positive 1, E99. For this part, our z-score negative 1.04, and here it's asking to find area to the right. So right of this one, right of our z-score, we have to find area for this part. This is the easiest method we can use to find the answer. If you try to use table, you have to find area to the left and then subtract that from 1 to be able to find area for area to the right. But here, if I use TI 8384, part A, probability when z is greater than. Here is asking to find area to the right. That's why here is greater. If it was left, we're gonna have z less than. But here is greater than negative 1.04. So that is, again, normal CDF. We always have to move from left to right, and starting point is, now in this case, is this number, z-score. And moving to right, here is our ending point as positive infinite. Then we have 0, mean, and standard deviation 1. So press second worst normal CDF, and we have to enter negative 1.04 and 1 E99. So this is what we have. Then enter. So our answer is 0.8508 run into 4 decimal place. So this was the answer for part A. You do exactly the same thing. You only need to change your z-score. So you're going to have exactly the same as this one, but changing z-score based on what is asking for part B, C, and D. Number 4, here asking to find area in between these two z-scores. I'm going to work on part A. So in this part I have So between is 0. And here on this part we have negative 2.15. And on the right side we have positive 2.15. Again, it doesn't matter what numbers are given. Here on this part we have same numbers but different sign. Here we have negative 2.37 and 0. And here we have 1.72, 1.95. So again, it doesn't matter what numbers you have. What matters is what it's asking you to find area in between. Here we have to find area between these two z-scores. So in this case, starting from left, here we have this number, moving to right, this is the ending point. So whenever you have between, you're not going to use negative infinite, positive infinite, because we don't have anything here on this part or on this part. So we're not going to use them. So finding the answer for part A, probability when z is between these two numbers. Again, using normal CDF. Here we have negative 2.15 comma, positive 2.15 comma, mean is 0, standard deviation 1. So these two stay same. Again, use second words, normal CDF, enter negative 2.15, 2.15. So this is what we have. Enter, 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 enter. The answer running to 4 decimal places, 0.9684. This is the answer for this one. You find the answer for B and C. Again, you have to do exactly the same as what I did here, but change the numbers that you have. You recall that from what we have in lecture. So I did all these, but I'm going to add this one here. Then we have z-score. So when z-score is given, and it's asking to find area or probability. In that case, you have to use normal CDF. So you have to use this function and enter what you have for starting point, ending point, mean is 0, standard deviation 1. So in this chapter, we had z-score. Sometimes we don't have z-score. In that case, we have to convert to z-score first and then use 0 and 1 here. If not converting to z-score, you're not able to use mean 0 and standard deviation equal to 1. What if area was given and was asking to find z-score? In this case, we have to use this function as inverse norm. So inverse norm, you have to press again second bars, and it's number 3. So normal CDF is number 2 and inverse norm is number 3. The inverse norm, here we have to enter whatever our area was. minus 0, standard deviation 1.